Fundamental theorem of calculus, we just call that FTC. So let f be a continuous function on interval a to b, and then we have a definite integral. So this is an integral from a to b, f of x dx, that is equals to f of a minus f of b, and then the capital F, the function, is the antiderivative of f. So let me tell you how the capital F and the lowercase f works. So let's say we have an integral. So here is what we are trying to say. So given f of x, so we have f of x, and then the capital F, f of x, that is equals to the integral of f of x dx, right? So let's say I have f of x equals to x squared, and then the capital F, so the capital F of x, so this is equals to the integral of x squared dx, so that is equals to 1/3 x to the third plus c. So this is how the capital F and the lowercase f works. So before we study the fundamental theorem of calculus, you have this, right? So this, the integral of x squared dx, so this is called indefinite integral. And then the integral from a to b, f of x dx, this is called definite integral. And a and b is called the lower limit and upper limit. So a is the lower limit, and b is called the upper limit. So fundamental theorem of calculus, the FTC, is not a hard thing to learn. All you have to do is you integrate first, like what you did back in the antiderivative, and then you perform one more step. So how do you perform that one more step? So let me tell you how in the next two examples. So in the next example, I have f of x equals to x squared plus 1, and then the interval is from -2 to 1. So first of all, we will set up a definite integral. So we have integral from -2 to 1, x squared plus 1 dx. So how do we do this? So first of all, we integrate, right? So how do you integrate or take the antiderivative of x squared plus 1? So this is easy. So for the x squared, you add 1 to the square. So this is a 3, and then you do the reciprocal, and then the integral of 1 is equals to x. So when you do definite integral, okay, definite integral, you do not do the plus c anymore. So as long as you see the lower and upper limit, you have to do the following. Just write a line, and then this line means such that x goes from -2 to 1. And then you apply the FTC. So apply the FTC means you use the upper limit minus the lower limit. So first, you plug in the upper limit. So we have 1/3 when x is equals to 1. This is a 1 to the third, and then plus x. So this is the plug-in for the upper limit, and then you minus the lower limit. So this is a 1/3, and then -2 to the third, and then plus -2. And then close the square bracket. So that is supposed to be a 1, but I wrote an x. So let me go back and fix that. So this is supposed to be a 1. And then you just do the arithmetic. So at the end, and this is equals to 6. Now, the next question is, what is the 6 represent? So the 6 represents the area under the curve of x squared plus 1, and x is between -2 and 1. Do you see that I prepare a parabola for you? So this parabola stands for x squared plus 1. And then what is -6 stands for? -6 represents this area. So we have an area under the curve. The area under this parabola from -2 to 1, the area is equals to 6. Right? So area is equals to 6. So that's what the result means. And then the next example, the area below the x-axis is negative. We talk about this when we are discussing Riemann sum, right? The area below the x-axis is negative. Okay, so let's take a look at this integral. So we have a definite integral, and then x goes from -1 to 1, and then x to the third dx. So first of all, we integrate. So the integral of x to the third, you add 1 to the 3, so that is a 4, and then you take the reciprocal of 4, that is 1/4, such that x goes from -1 to 1. Alright, so x goes from -1 to 1, so that means we have this piece and then this piece, right? So since without the evaluation, let's take a look. We have one piece above the x-axis and then one piece below the x-axis. So if you just take a look, you say, well, they are symmetrical. So that means the piece below the x-axis is the same as the piece above the axis, but since the piece below the x-axis is negative, right? So this is supposed to be positive, this is supposed to be negative, so they're supposed to be cancelled. So at the end of the day, the total area is equals to 0. So let's go ahead and find out. Okay, let's plug in a 1. So when you plug in a 1, you have 1 over 4, 1 to the 4th power, right? Plug in a negative 1, you have a 1 over 4, negative 1 to the 4th. So that means you have a 1 over 4 minus 1 over 4. So that is equals to 0. So what is this 0 represent? So that is equals to 0. So this is area under the curve of x to the third from negative 1 to 1. So that means this area plus this area is equals to 0. So let's break down the integral. So if you just take a look at one integral, so just take a look at the integral from 0 to 1, x to the third dx. So that gives you a 1 over 4 x to the 4th from 0 to 1. You plug in a 1, you have a 1 over 4, right? You plug in a 0, you have a 0. So that is equals to 1 over 4. So that means this is 1 over 4. How about the piece below the x-axis? Let's take a look. So we have integral from negative 1 to 0, x to the third dx. So this is a 1 over 4 x to the 4th from negative 1 to 0. So when you plug in a 0, you have a 0. You plug in a 1, you have a minus 1 over 4, and then negative 1 to the 4th. So negative 1 to the 4 is just a 1, 0 minus 1 over 4, that is negative 1 over 4. So area can be negative as long as the area is below the x-axis. So you have a negative 1 over 4, a negative plus a positive, so they just got cancelled. So at the end of the day, the total area is equals to 0. So that's how the fundamental theorem of calculus works, and that's how the definite integral works. So overall, when there is, so let's say you have a x squared and then dx, when there is no upper and lower limit, we call this indefinite integral. So for indefinite integral, your answer is supposed to have a plus c at the end. But if you have a lower limit and upper limit like this from 0 to 6, then this is called a definite integral. Alright, so that is the end of this video. If you like it, give me a like, share, and subscribe, and I will catch you all in the next one. Signing out.